Hello, everyone, and welcome to A1 Tutor Live class, physics class. I believe you guys are doing very good. Okay, so once again, we are welcome to our live classes. And today, we are going to be considering a new topic in physics. We've concluded motion as at yesterday, and today we are going to dive into a new topic. All right, we're going to dive into a new topic. Before we proceed, I would like to ensure that everyone can hear me. I want to be sure that you can hear my voice, and as well, you can see the board. So if you can hear me, just type yes in the chat box or thumbs up so we can proceed. If you can hear me, just give a reply in the chat box. All right, okay. Thanks for your response, Sadu Emmanuel. Okay, let's proceed. Today, I said we are going to consider a new topic. And to introduce our topic, we're going to consider a picture. Okay. All right, so I'll be sending some pictures to us that we'll be using for today's class. Okay, so I'll be sending the pictures in our chats. All right, so loading. So today we are looking at another topic, like I said. And to start with, we want to introduce the topic for today. Now, we are going to be looking at a new topic, like I said. Now, let's take an illustration of this diagram that we have on the screen. I believe everyone can see the screen properly. So using this diagram, we want to introduce what we'll be dealing with today. I believe most of us who are science students know this man, Isaac Newton. Yeah, that is one of the greatest scientists we have in the field of science. So today we are dealing with a topic that is kind of related to this scientist. All right. Now, from the image you have in your chat box, you could see that we have a man falling and we have an apple also falling. The question is, what is the cause? What is actually causing this? That a man is falling and also an apple also is falling, and both are falling towards the ground. Okay, so now let's do an illustration. Let's take an example. Our parents in Nigeria, especially our mother, they are always being conscious of where we go to ensure that we do not go to places we're not supposed to go to. So most of the time, our mothers monitor our movements, and if you are trying to act funny by going to where you're not supposed to go to, the next thing you see your mom will do is to pull you back, that you have to come back to the place where you are supposed to be. So she won't allow you to go to where you want to go. Why? Because she has the strength to pull you back from where you want to go to. Are you getting it? So one way or the other, we can attach this to the topic of today, that the force that pulls you back when you want to do some things as a child, or when you want to go to a place as a child, that force it has a basic in physics. And that force is what we call the gravitational force. The force gravitational does not allow most of us on planet Earth to float. Imagine if gravity was not existing, what would have happened to most of us? We'll be floating in the space. The plates in the house, the spoon in the house, the food, everything will be floating if gravity was absent. I believe you get my point. So gravity is the force that pulls us towards the center of the earth. So where do we have the force exacting from? The force is exacting from the center of the earth. So gravitational force is a force that is produced by the center of the earth. And that is why most objects, when you throw an object upward, it has to come down again to the what? Surface of the earth. It is not just natural. There's a force that pulls that object downward. And that is what we have in this picture. A force is pulling this man downward to the surface of the earth. And the same force also is pulling this apple downward to the surface of the earth. Just like our parents, our mothers, when you want to do something, they will ensure that if what you want to do is wrong, they will pull you back and stop you from doing that thing. So the process of them pulling you back is what we call gravitational force. So today, we want to consider a topic called gravitational field. Gravitational field. And we can't talk about gravitational field without mentioning gravitational force. So from this introduction, we understand that the force that pulls objects or that pulls the body or a particle towards the surface of the earth is called gravitational force. All right. So let's consider the topic now. Gravitational field. Gravitational field. Now, gravitational field is what we are going to consider as a topic today. Gravitational field. We've explained with the introduction what gravitational force is all about. Now we want to consider gravitational field. First, we need to understand what a field is. So let's break it down. What is a field? A field is a region. A field is a region in space where an object would experience a force. A field is a region in space where an object may experience a force. The picture we use in the introductory part, you could see that the man falling and the apple falling are in the space, but they are experiencing a force that is pulling them downwards to the surface of the earth. So that region where they experience a force, which was a gravitational force, is said to be a field. It's said to be a what? A field. And we have two types of field, but for today, we want to consider the one we call gravitational field. Another type of field is electric field, but that is not for today. For today, we want to consider gravitational field. Gravitational field is an area in the space where an object would experience what we call gravitational force. So the field, the space whereby an object experiences gravitational force, that space is referred to as the gravitational field. Okay? So if I should refer you back to this diagram that we used initially, okay, using this diagram, okay, we can see that this man is in the space. Likewise, this apple is also in the space. So at this space, when they're experiencing the force that is pushing them downward or that is pulling them downward, that space is said to be the gravitational is said to be the gravitational field. The space where this man was experiencing gravitational force and this apple also is called the gravitational field. It's called the gravitational field. So that is what we are going to consider today, and we'll be doing much of calculations. But it is good that we understand the concept of gravitational field. So that is the definition of gravitational field. It is the space or the region where a body or an object experience a gravitational force, whereby a body or an object experience a gravitational force. Okay, so let's proceed to the law of gravitational force. The law of gravitational force, also known as the law of universal gravity or universal gravitational force. That law was propagated by Isaac Newton. That was the man I showed you in the first image. The law was propagated by the man called Isaac Newton. So it was named after him. It is called the law of universe. It's called the Newton law of universal gravitation. The Newton law of universal gravitation, because it was created, let me say it that way, the law was created by Isaac Newton. Okay, so let's consider that law, the law of universal gravitation. Okay, so this is the law of universal gravitational, the law of universal gravitation. What does it state? It said every object in the universe attracts, we need to underline the key points, every object in the universe So every object experience gravitational force. Every object experience gravitational force. Every object in the universe attracts every other object with a force directed along the line of centers for the two objects that is proportional to the product of their masses, and inversely proportional to the square of the separation between the objects. So let's use this illustration. We have object 1 with its own mass as m1, object 2 with its own mass as what? m2. Now, there's a force that brings these two objects together, a force of attraction that brings them together. That force is what we call the gravitational force. So Newton was able to deduce this law from taking an experiment of how the Earth's surface, and other objects in the universe, that is, other objects in the Earth, the way they attract each other. Every object on the Earth's surface or in the universe is attracted by the Earth. Every object. Okay, to do that, let me give us one diagram for that. All right, okay. We'll go back to the law, but let's look at this diagram first. Now we have a tree, and there are apples, or let me say oranges, on this tree. And what you observe was that the oranges or the fruits on this tree were just falling down on their own. No one was plucking them. No one was actually using a force to push them down. But naturally, we discovered that those fruits were falling down on the ground. Now, what is responsible for that is what we call the gravitational force. The Earth's surface, where this man is sitting here, and symbolizes the Earth, and there is a force that pulls any object towards the center of the Earth. And that is why those fruits were falling. The force that comes from the center of the Earth, which is called the gravity, the force of gravity, is pulling those orange towards the center of the Earth. And that is why you see that those orange were just falling to the surface of the Earth. It's as a result of the force called gravitational force, which is manufactured by the surface of the Earth towards the center of the Earth. So gravitational force is the force that pulls an object towards the center of the Earth. So imagine every object, every body, every particles on the surface of the Earth experience gravitational force. And that is why sometimes you see you want to fall. There's a force pulling you. Sometimes you see you hold an object, and mistakenly, when it falls from your hand, it goes towards the surface of the Earth. It goes to the ground. If not, the object falling from your hand should stay in space and be floating. But it won't be floating. It will go down to the surface of the Earth because there's a force pulling that object to the surface of the Earth. All right. So let's proceed with our law. Okay, so we are back to the law we're actually trying to interpret. So this is an object. This is an object. So assuming this M2 is the Earth, all right? And assuming this M1 is probably an orange on a tree. So there's a force bringing the orange towards the direction of the Earth. And that force is called the gravitational force. So Newton expressed that formula or that law to be mathematically expressed as F varies directly proportional to the product of the mass 1 and mass 2. That's M1 m2. Okay, and also that force is inversely proportional. Inversely proportional. So we have another varies inversely proportional to the square of their distance. So the distance is represented by r. The distance between the two bodies is represented by r, square of it. So this is now simplified to be F varies. If this is going to be over 1, I'll multiply the product here by 1. I'm going to have 1, M1, M2, all right? Okay. Okay, let's continue from here. F varies as M1, M2, varies inversely proportional as R squared. If this is over 1, we can say F varies, multiply M1, M2 by 1, that is M1, M2 over 1 multiplied by R squared is R squared. F varies directly as the product of M1, M2 over R squared. Now, if I'm to introduce the constants, because Isaac Newton later introduced a constant, which was the value for the Earth's gravitational force. He introduced that constant. So if F equals to, now we have changed from varies to equals to, we need to introduce a constant. When we take away the sign of variation here, we have to introduce a constant. And the constant will be capital letter G, M1, M2, all over R squared. So the force of gravitational Fg is given as this expression. The force of gravitational Fg is given as this expression, where G is a constant and G is given as 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. The value of G is 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. So this is a constant that will not change except the question states otherwise. So I believe you are with me and you understand what we've just done so far. So we have been able to derive the formula of gravitational force. The formula of gravitational force. Okay, if you are following me and what we have explained so far is clear to you, please kindly react by sending an emoji so we can proceed. Okay, thank you, Emmanuel, for your response. Okay, thank you. Thank you, Peace. Thank you, Temilola. Thank you, Sulia. All right, so let's proceed now. Now we want to consider another subtopic, and that's going to be weight and mass. You know, people used to do some kind of, should I call it an error? They think weight is mass, and they think mass is weight. So we want to consider the differences between weight and mass. The differences between weight and mass. All right. So I'm going to clean the board. Take note of this formula. We'll be using it in calculation. Okay, let's proceed. Weight and mass. All right. So let's make use of this picture. All right. So this is a picture we are going to use to explain what weight is. Weight. You know, sometimes you say, I'm going to the gym. I want to go and carry weights and all that. So what is weight? We want to look at what weight is. Now, the picture here is showing someone at the gym carrying a lift, trying to do what we call lifting of some objects that has mass, actually. Now, as this man is trying to pull, as this man is trying to pull the objects upward, All right. There's another force that is working as a resistance force against the process. Okay. So he's trying to lift this upward. But there's another force that is pulling that thing downwards. The job of the man is to ensure that he lifts this thing upward, and another force is responsible for pulling that thing downward. So he finds it so difficult to pull it upward. Why? Because there's a force that comes against him. Okay, that force is what we call weight. That force is what we call weight. The force that acts against an upward movement direction. The force is what we call weight. So you can see the arrow here, the arrow we have here, showing that weight has to do with a downward movement. So the force that pulls him downwards is called weight. And that force is nothing but is still what we call the gravitational force. The force is trying to go against the movement of the man. So weight is the force that goes against a normal movement, which is supposed to be upward. The force that goes against that movement is called weight. It's called what? Weight. So expressively, we can say weight has to do with gravitational force also. So weight has also to do with gravitational force. So weight has to do with what? Gravitational force. Now, what about mass? Mass. Mass is the quantity of a matter. Quantity of a matter. All right. So when you have an object that is probably a matter, whether solid or liquid or gaseous, they have their own mass. So the quantity of that state of matter is said to be the mass. Okay. So to explain that, let's consider this image. Now, this one is talking about weight, and this is talking about mass. I believe we are familiar with these objects. It is used for getting the quantity of an object in terms of what? Mass. In terms of mass. Okay. So this is talking about mass. We are trying to get the quantity of these fruits and the quantity of these fruits. And you know that mass is measured in kilogram. Mass is measured in kilogram. And here we are talking about weights. Now, this guy is pushing this wheel. Okay, let me say he's pushing this object towards this direction. And there's another force that comes against that movement. And that force is what we call weight. And that is why when you solve calculations under weight, weight is taken to be measured in Newton. Why? Because it has to do with force, a force going against a movement. All right. So this is going to be measured in Newton. Take note, weight is measured in Newton, mass is measured in kilogram. So we said mass is the quantity. From the definition, mass is the measure of the amount of matter in an object. It's also the quantity of matter. So the measure of the amount of matter in an object is said to be what? Mass. Is said to be mass. Are you getting it? So you can actually get the mass of an object if you are conversant with some objects. In physics lab, we have 5 kilogram. When you are working on some experiments, we have 5 kg mass, we have 10 kg mass, depending on the weight of that particular object. Take note, weight and weight is different. Weight is talking about force that moves against a particular upward movement or a force that moves against a particular movement. But this way talks about the measure of amount of a matter in terms of what? Mass. In terms of what? Mass. Okay. So we need to know what are the differences between mass and weight, because in UTME, you can be asked questions related to that, the differences between mass and weight. So this table will summarize what mass is and what weight is. Okay, weight is determined by what? Gravity. We talked about that. That weight has to do with gravitational force. So weight is determined by gravity, but mass is not determined by gravity. Mass is not determined by gravity. Weight changes depending on where you are in the solar system. Weight, it changes depending on where you are in the solar system. And as for this, mass stays the same wherever you are in the solar system. So your weight is subject to change depending on your position on the solar system. If you're on Earth, your weight, your weight is different from where you are on the moon. Are you getting it? Because the solar system consists of the Earth and other planets. Are you getting it? So my weight on the Earth is different from my weight on the moon. So they have changes based on the location on the solar system. But as for mass, it is the same anywhere, everywhere. If the mass of an object is probably 5 kg on Earth, when you take it to the moon, it's still 5 kg. It does not change. Okay, so mass remains the same wherever it is in the solar system. Weight is force, but mass is not force. Weight is force, but mass is not force. Okay, weight is measured in Newton, mass is measured in kilogram. So these are the differences between weight and mass. And we need to master these differences because in UTME, you can be asked questions that are related to these differences. All right. So I believe we are getting that. Okay. If the differences between mass and weight is clear to us, please thumbs up. So we'll move to the next one. We have many calculations to do today. Okay. Thank you, Temilolua and Sabi Emmanuel. Thank you for your response. Okay, so let's proceed to the next item on our topic. We want to discuss about another subtopic still under gravitational field. Still under gravitational field. Now we are going to consider weightlessness. Okay, weightlessness. Okay, so I have a picture that will make that more easier for us to comprehend. Okay, weightlessness. So let's look at this picture. Then I'm going to give us the definition also. All right, so I'm going to drop the definition for us. So the definition of weights all right, okay. So let's work with this. Now we have weightlessness as the next thing we are discussing about. Weightlessness from the word. This is a normal English. Weightlessness. That means it does not have weight. From that word, if you have to define it literally, that means something that does not have weight is said to be a weightlessness object. Okay, but let's look at the definition in the context of physics. Weightlessness is a condition in which an object appears to have no weight. A condition whereby an object appears to have no weight is said to be weightlessness. So in simple definition, weightlessness means a situation or a condition whereby an object has no weight. All right. So now let's look at this diagram. we have the astronauts in their ship, or let me say the astronauts in their plane. And what you observe is that the astronauts are they are kind of floating. They are kind of floating inside the plane. All right, inside their plane, they are kind of floating. So what has led to this process whereby these astronauts are floating? It is because the astronauts are in a particular they are in a particular space in the solar system. You know, we said weight is subject to change based on wherever you are in the solar system. So this is obvious that the astronauts are not on the surface of Earth, because on the surface of Earth, gravity is present. So if gravity is present, that means we have what? Weight. So of course, looking at this picture, these astronauts are no more on the surface of the Earth. Probably they've traveled to another planet, let's say the moon. So they've attained a condition where gravity does not have, where gravity is not present. Let me say it that way. Where gravity is not present. So the absence of gravity has now led to weightlessness, and that is why they are floating. Are you getting it? You know, I said from the beginning of the class that in introductory part that let's imagine if gravity was not existing, all of us on the surface of the earth will be floating. Will be floating. Every object, gadget will be floating. But because we are on the surface of the earth, we are living on the surface of the earth, and the earth has gravitational force. That means all of us are subject to that force, and that is why we can't float. We are walking. And even though if you throw an object, you still have to come back to the surface of the earth. But as the condition of these people here, the astronauts, they are in another solar system, in the moon, where gravity is negligible, where gravity is absent. So that is why they are floating. So weightlessness is a condition where gravity is absent or is nearly absent. Okay? Or we say weightlessness is a condition where an object, or probably an object has no weight, a condition where an object has no weight, possess no weight. Are you getting that? So looking at these people, they have mass. Of course, you know, we are trying to differentiate between weight and mass. These astronauts have their mass. And if peradventure this man here is weighing 65 kg on Earth, if you check his weight also, even while he's still in the moon, he's still the same 65 kg. So the mass remains the same, but the weight is changing based on location. So weightlessness is the condition in which an object appears to have no weight. So that's a simple definition of what? Weightlessness. Okay, so I believe that is clear to us. We are going to proceed. If it's clear to us, please kindly signify. We are moving on to the calculation aspects. I want to have your reaction if the definition, the concept behind weightlessness, if it is clear to you, please signify so we can move on to the calculation aspects. Okay, thank you for your responses. Now let's dive into the calculation aspects. Okay, the calculation aspects. I'm going to rub the board. So we go back to our board. We want to use our board now. We're needing that. All right, so let's proceed. So we're going to have calculation on three, or let me say four aspects under gravitational force. That is gravitational force itself. We are going to have calculation under potential gravitation, energy, okay, and escape velocity. We are going to have calculation under those headings. So let's start with the first calculation, and that will lead us to application one. Application one. So I'm going to write out the parameters to make it more easier and faster. The gravitational force between two objects, masses 10 raised to power 24 kilogram and 10 raised to power 27 kilogram is 6.67 Newton. Calculate the distance between them. In brackets, capital letter G equals to 6.6 times 10 raised to power minus 11 Newton meter square per kilogram square. All right. So this is the question we want to solve. So this is the first application we want to consider. The gravitational force between two objects, masses 10 raised to power 24 and 10 raised to power 27 is this value. Calculate the distance between them. One of the hints when you are solving physics is that first understand your question by identifying the parameters. All right. So in the question, we are given masses of the objects. This is the first mass, and this is the second mass. All right. So the question says the gravitational force between two objects of this mass and this mass is this mass, and also we are given the force between those two mass. All right. And what else again are we given? We are given G, which is the gravitational constant. So we have to write it out. Solution. Write M1, which is the first mass, 10 raised to power 24 kilogram. M2, 10 raised to power 27 kilogram. All right. Force, gravitational force, 6.67 Newton. Gravitational constant, 6.6 times 10 raised to power minus 11. And you have to understand what you are asked to find. Okay, calculate the distance between them. And when we are trying to explain the law, we said there's a distance between them, and that distance is what? R. So R is what? R is question mark. We don't know the value of R. So we want to get the value of R. All right. So to do that, we write the formula Fg. Let's make use of black ink. Fg equals to Gm1 M2 over R squared. As a student of mathematics, okay, so let's proceed. As a student of mathematics, you can make R subject of the formula. That will make your work very easy. You can make R subject of the formula. And that's what we want to do together. If this is going to be over 1, then I need to cross multiply. R square multiply Fg. That is Fg R square equals to Gm1 M2. All right. So the aim is to get R square as the subject of the formula. So I have to divide both sides by what I have beside R, which is what? Fg. So Fg, R square rather, will be equals to Gm1 M2 over Fg G. All right? We are still having R squared, but we want to get R. What we want to get is what? R. So I need to take away that square. How do I take away the square? Is by taking the square root of both sides. So square root of R squared, square root of G M1 M2 over FG. All right. So the final response, which is R, will now be equals to the square root of G M1 M2 over FG. So with this formula now, we can get the distance between the two objects, all right? So permit me to clean this portion. I believe it's clear to us. Can I clean this portion so we can solve the numerical aspect of it here? Okay, so I'm going to clean this portion so we can proceed to solve with the value given to us in the question. Okay, we proceed to solve and get what R is exactly. All we have left to do is to substitute the given information or the given parameters into the formula we've derived. All right, so we have F now. We have R. We are looking for R. R equals to G. What is the value of G in the question? The value of G is 6. Let's have the square root on it. 6.6 times 10 raised to power minus 11 times, what is M1? M1 is 10 raised to power 24. 10 raised to power 24 times M2. M2 is 10 raised to power 27. Okay, everything is over. Everything is over FG. FG was given to be 6.67. The value of FG was given to be 6.67. 6.67. So R equals to, we need to simplify this. If you multiply this all through, multiply 6.6, let's have that separate. Now let's deal with the index form from the law of indices that you understand. 10 raised to power minus 11 times 10 raised to power 24 will be plus 24 as the power times 10 raised to power 27. Then you have plus 27. And that will give us 10 raised to power minus 11 plus 24 plus 27 minus 11 plus 24 plus 27. That will give us 10 raised to power 40. So we have times 10 raised to power what? 40. Okay? 10 raised to power 40 over 6.67. Okay? So now let's go on to simplify this. R equals to divide 6.6 times 10 raised to power 40, all right, divided by 6.67. What are we going to have? We have 6.6 times 10 raised to power 40 over 6.67. So we are going to be having 9.895. Approximately that will be 1 times 10 raised to power 39. So all we have to do now is to get the square root of this expression. Getting the square root of this expression. So we are going to get the square root of this expression. The square root of the answer we have, that will be 9.947 4 times 10 raised to power 19 times 10 raised to power 19. And because we are calculating for r, we are calculating r, which is what? Radius. And in physics, we've studied that when we are dealing with length, whether radius or your length or your breadth, we are going to make use of what? Meter. So the SI unit for the radius is going to be in what? Meter. So the final answer will be 9.9474 times 10 raised to power 19 meter. So the radius or the distance rather, not r represents distance, not radius. The distance between the first mass and the second mass is 9.9474 times 10 raised to power 19 meter. So that is going to be the answer. All right. So if this is clear to us, please let's signify. So we move on to the second calculation. Okay. Thank you for your response. Okay. All right. That means we are good to move to the next question. So I'm going to clean the board now, and we take the second application. The second application. Up to the first example we did was a question under gravitational force. Now let's look at question under escape velocity. If the radius of Earth is 6.4 times 10 raised to power 6 meter, comma, the escape velocity, of a satellite, a satellite of a satellite from the Earth, is dash. Take g equals to 10 meter per seconds. Take g equals to 10 meter per second square. All right. So we are asked to calculate escape velocity. So what is escape velocity? I have a diagram for us. I'll just quickly explain the concept behind escape velocity. Then we'll move back to the question. Okay, so escape velocity. This is the Earth's surface. And we said that gravitational force is present on the Earth's surface. So that means if I can leave the Earth's surface, I've escaped gravity, right? That is where we have the terminologies escape velocity. Like you are saying, Jakpa velocity. Are you getting me? So when an object escapes the presence of gravity and is no more under the force of gravitational force, that particular object is said to have obtained an escape velocity. And we have two satellites here. The first satellite, we have two satellites in this picture. This is one satellite. This is a satellite, another satellite, right? Now you will see that this one, let me label this one as 1 and this as 2. The satellite labeled as 1. It tried to escape the surface of the Earth and also to escape the gravitational force. But the gravitational force of the Earth was so strong to the extent that it has to bring back the satellite to the surface of the Earth again. Are you getting it? It has to bring back the satellite to the surface of the Earth again. You know, the Earth is spherical. So the scientists, what they do is that they send satellites to the what? The outermost part of the what? Of the Earth to be able to do some kind of research. But sometimes those satellites cannot go beyond their boundary. So the ones that go beyond the surface of the Earth have the one that goes beyond the surface of the Earth is said to be the satellite that have escaped the force of gravity. And that is what we call escape velocity. So The one labeled as one, the first satellite labeled as one, has to come back to the surface of the Earth because it was unable. The satellite was unable to escape the what? The gravity. But the one labeled as two, you can see, has left the surface of the Earth. So this one, this satellite labeled as two, has escaped the force of gravity. So it has escaped the force of what? Gravity. And that is where we have the terminologies escape velocity. So at that moment, the velocity at which the satellite is moving is called an escape velocity. All right. So now let's go back to the calculation now. Go back to the calculation so we can solve it. Now the question we're about to solve the other time, we are given the radius of the Earth and the escape velocity we are asked to calculate. So let's identify informations. We are given radius of the Earth. We are given radius of the Earth. So we have R is the radius of the Earth, which is 6.4 times 10 raised to power 6 meter. All right. And we are given G to be 10 meter per second square. And we are asked to find escape velocity. Escape velocity, question mark. So what is the formula of escape velocity? Escape velocity equals to the square root of 2gr. 2gr. So if you are going to substitute the informations you have, that means v escape equals to the square root of 2 times g is what? 10. That's 10 multiplied by the radius, capital letter R, 6.4 times 10 raised to power 6. All right. So we are going to simplify this. Let's take 2 times 6.4 first, then multiply 10 raised to power 1. Invisible 1 is here, times 10 raised to power 6. So we'll be having square root of, multiply this together first, 2 times 6.4, 2 times 6.4, that will give us 12.8 times 10 raised to power 1 times 10 raised to power 6. That will give us 10 raised to power 1 plus 6, 1 plus 6 as the power, and that is 7. Okay, still following the law of indices. All right. So this now, we are going to find the square root of this. V escape V escape is going to be the square root. Find the square root of this value. So the square root of 12.8 multiplied by 10 raised to power 7 multiplied by 10 raised to power 7 will give us 11,313.7085. 0.7085. Okay, so escape velocity has its own parameters, has its own units, and it is measured in meter per seconds. So the escape velocity for this question is 11,313.7885 meter per seconds. Meter per seconds. Okay, I believe this is also clear to us. If the second application is clear to us, please signify all right. Okay, thanks for your response. Okay, thanks for your response. Now let's proceed. Now we are going to consider some questions. We stop on 2 applications. Then I'm going to give us some questions that I want us to solve together. That will be like an evaluation for us based on what we've done today. All right. So permit me to clean the board. Okay. So let's look at this question together. Okay, the first evaluation question. All right. So we have this question for us. We are going to solve this for me. Evaluation. So I believe we can see the question. So we ask this question, the force with which an object is attracted to the earth is called dash. So in the chat box, I need your response. In the chat box, I need your response. This is the question. I believe you can see the question. So you are asked the question, the force with which an object is attracted, all right. Okay, Teminolua said gravity. That is correct. Gravity. Gravity is the response. Yes, gravity is the response. Good. Okay, one more question. Let's take one more. Okay. Okay, another question. All right. Okay, let's look at this question together again. Yes. So this is the second question for us. The objects, the objects, an object is way at different location on the earth. What will be the right observation? We've discussed this while we're explaining the concept of mass and weight. Okay, C. Okay, someone give us the response C. The mass is constant while the weight varies. Perfectly correct. So you know we said that the mass is constant and the weight varies. It changes. Okay, that's good. So one more question so that we can round up for today. One more question so we round up for today. At this time around is going to be all right. Okay, this one is going to be a calculation question. Very fast, you just need to get the response. All right, so you check your chart, you will see some questions loading. So we're going to do one of it, and the one that will be very fast for us to solve. Okay, this. Let's go for this. So we have a UTME question, 2014. UTME question 2014. Calculate the escape velocity of the satellite launched from the Earth's surface if the radius of the Earth is this value. If the radius of the Earth is this value. So I'm waiting for your response. Waiting. I'm waiting for your response. You are going to make use of the escape velocity formula, which is V escape equals to the square root of 2GR. G for this question, sorry, take G to be 10 meters per second square. Your R is given already. Your R is 6.4 times 10 raised to the power 6. So this is all you need to solve the question. So I'm waiting for your response. what will be the value? Just slot in all this information, these parameters inside the formula of escape velocity. Waiting for your response. (11.3) Temilolua, 11.3 kilometer per seconds. All right. So we have a response for option D, that option D is the correct answer. So simply substitution, by doing substitution of that, you are going to have the square root of 2 times 10 meter per second squared times 6.4 times 10 raised to power 10. And of course, if you are very conversant with the example I did lastly, it's almost the same question. Yes, it was even the same dimension, the same value that was given. All right. So that answer is going to be the response, because the first one I got, I wrote the whole answer together. But in this case now, it was written in kilometer. The value was given in what? Kilometer. So the answer is what we have in option D. The answer is what we have in option D. 11.3. 11.3 kilometer per seconds. That will be the what? The response. 11.3 kilometer per seconds. All right. So that is going to be the response. Thank you for your response, Temilolua. That's a great performance from you. So that will be the response. All right. So for us to still practice more questions, please, I will urge us to visit the A1 Tutor app. There are a lot of questions under the CBT section for the topic gravitational field. All right. So do well to practice question on that, just to ensure that you still have the formula in mind. Okay, you need to practice more questions. So today we have been able to discuss the concept of gravitational field, and we said we cannot talk about gravitational field without mentioning gravitational force. Okay, so we said if gravity is not existing, everybody will be floating in the space. But thank God that we have gravity, so we are not floating. We also discussed about what mass is and what weight is. We're able to check the differences between mass and weight. We also consider the universal law of gravitation, which was propagated by Isaac Newton, one of the scientists we have in the time past. We went ahead to discuss about weightlessness, and we said it is a condition whereby an object has no weights. Okay, then we went ahead to take some calculations on gravitational force, velocity, escape. Okay, velocity, escape. So do well to make use of those formula that I've sent to you through your chats and practice questions. Okay, if you need more details explanation about gravitational field, visit A1 Tutor app and check under SS3. You have the topic gravitational field. So you have a detailed video to make your understanding more easier. Okay, so watch the video on that and understand. You have a lesson note also under it on that same app, and practice question under gravitational fields on that same app, all for free. So you have no excuse. You just have to go there and do the needful. Okay. And also, for the sake of our friends who are unable to join us today again for our class, please always have it in mind to tell them to visit the A1 Tutor YouTube channel for the videos of all the classes we're having. The one of today will be available, and that of the previous classes for all subjects is also available. Do well to watch, to refer them to it, and also do not just watch, like, share, subscribe, and also comment. Okay, do well also to rate our app on Google Play Store and on iOS. Thank you. We really appreciate you for your time. See you tomorrow. Tomorrow is another day. Ensure you are in the class. Ensure you are punctual. Ensure you don't miss any part of this live session. Thank you. Thumbs up if you are with me. I want to see your reactions as we are closing for today. Thumbs up. Okay, thank you. Thank you. Thank you. I appreciate your response. Bye. See you tomorrow.